Student, good afternoon. Welcome back to Mr. Chen's master class. So today I would like to continue to talk about the 4.6. Okay, so 4.6, which is the tangent, cotangent, secant, and cosecant graph. So we'll take a look at this in a minute. So graph one cycles of y equals cosecant of x and y equals secant of x. So state the domain and the range of each. Okay, so started off with this one. So for cosecant, we do know that this one is just the reciprocal function of sine. So you can always start it off with the sine curve, the reference graph first. So one cycle, sine is always considered a roller coaster. So started at 0, 0, and then pi over 2, and then right up here at 1, and then pi goes back down to 0, 3 pi over 2, then all the way down to negative 1, and then 2 pi back to 0. Again, reference graph, so that means dotted. It's always dotted. And then what we know is that at 0, it's always the VA, because that cosecant, it's always the reciprocal function of sine. So VA, so the first VA is going through the y-axis. And the other VA, it's right here at pi. So the third VA, 2 pi. All that. And then this one here, we just want to make the parabola. Okay, so another thing is that half of the cycle, half of distance from 0 to pi over 2 is pi over 4. So cosecant of pi over 4 right here, then that'll be 2. Okay, so 2, symmetrical 2. And then also right here, down negative 2, negative 2. Connect the max, the vertex and then the points. Okay, so like that. And right here too, connect the vertex along with those points. Okay, so the cosecant graph. And then the domain for this one. So the domain, this one, well, if this one goes all the way from negative infinity to infinity, you can say that there's some kind of exception. So except 0, pi, and the multiples of pi. So for the parent graph, if you want to state the domain, so you can say that it's all real number except zero, pi, and pi k. Okay, and where k, it's any integer. And then for range here, so the range is also pretty obvious. So the range, you can say that it's from negative infinity all the way to negative 1 bracket. And then union, open bracket, 1 all the way to infinity. And now what about for the secant graph? The secant graph is based off the reference graph of cosine. So cosine is always a bell curve. So started at 1. 0, 1, all the way down to 0, 0.5 pi, 0. And then at pi goes all the way down to negative 1. And then 3 pi over 2 goes back to 0. And then 2 pi goes all the way back up to 1. And again, at the 0, so we do have a VA. And now the VA. So what I'm doing here, just this one is just like a one cycles of the graph. Okay, you can always continue with that. Okay, so this one, half of a parabola. Here's another half of the parabola. Well, the other one is a full upside down parabola. And this one here is the other half. Again, it's symmetrical because that secant, it's an even function. So state the domain for this one. So the domain for this one, then that'll be all real number except pi over 2 and pi over 2k and where k is any integer. Okay, so now let's see what else. So graph 1 sine cos of y equals negative cosecant of pi minus 2x plus 1. State the behavior from the left and from the right of each vertical asymptote. So test the vertical asymptote. So first thing that you want to do, so just rewrite it with the ultimate form, the factor ultimate form. So this one could be written as negative 2 cosecant of, let's just swap that, negative 2x and pi. Okay, so just swap that because addition is considered commutative. And also take out the negative sign. So what we found here is negative 2x minus pi. So cosecant of negative theta, we do know that it's an odd function. It's the same as negative cosecant of theta. So negative, negative, so that turns out to be positive. So positive 2 cosecant of 2x minus pi plus 1. So it's always easier to simplify the equation first before you make any kind of identifications, identifying that a, b, h, and k, all that. And also this one we can take out 2 cosecant of 2 times the quantity of x minus pi over 2, and then plus 1. So the amplitude, well, it's not the amplitude, just the initial position or the initial height, 2, or the scale factor, okay? So the vertical stretch factor. And then the other one, it's a horizontal stretch factor, then that would be 2. So that means the pure is 2 pi over b, 2 pi over 2, which is pi. So h is pi over 2, and then k is 1. So in order to do the one cycle test, this one we can just say that is from 0 all the way to 2 pi, but 0 and 2 pi, they're not included, because according to the parent graph, those are the VA. Okay, so let's find out the one that we need to put in here in the middle. So we put in the quantity, 2x minus pi. Solve for x, so add pi both all sides. Okay, so 3 pi. And then divided by 2. So pi over 2. Divide everything by 2, and then ends at 3 pi over 2. Okay, so one cycle. So started at pi over 2. And finish that at 3 pi over 2. And then the one that we have, it's a VA, so pi over 2, that's the first VA. And other VA right here, obviously is right here at pi. And then 3 pi over 2, that's another VA. So we just follow through the pattern of the original, the parent function. And then one thing that we noticed, the parent graph, so this one amplitude is 2, up 1. Okay, so that means it's up 3 for the max, for the reference graph. So let's just set up the scale, 1, 2, and 3. Negative 1, negative 2, negative 3. So instead of starting at 0 for the reference graph, you started here at 1. And then up 3, back down to 0, back down to 1. And then negative 2 plus 1, then that'll be negative 1 over here. And then finish that at 1. Okay, 3 pi over 2 at 1. Again, reference graph, dotted, not solid, because that's not part of the final graph. And then for the final graph, so let's use different color for this one. So again, at the max and the min right there, so those are the vertices. And then we do know that it's the value of a is 2. Okay, so that means the scale factor here, so it's 2 units, all the way up to 5. Okay, right here. So that means it's a vertical stretch. And also right here, all the way down to, well, negative 1 minus 2, all the way down to negative 3, vertical stretch. Okay, like that. So for those you might be wondering, the parabola is kind of skinny. Well, the reason why that is because the vertical stretch factor, which is what? By 2. So normally this one, if the initial amplitude, the scale factor is 1, so that means just like a normal parabola. But right now it's being stretching out with that vertical stretch by the factor of 2. So this one is like 2 units right above the initial position. Okay, for those 2/4 of the scale. Okay, so now let's see what else. Okay, so this one, oh, you know what? State the behavior from the left and from the right of each vertical asymptote. Well, that's what we did. Okay, so the behavior to make it narrow. And then grab 1 cycles of y equals tangent of x and y equals cotangent of x by using the unit circle. This one, there's no need to apply the unit circle. I mean, you can do that as well. But one thing that we know, tangent of 0, it's always consider 0. And then tangent of negative pi over 2, that's a VA undefined. And then